Let's find some components of vectors. First of all, I hope you'll forgive that the writing is running off the edge of the screen. You'll have to take some of this information verbally. Let's have a vector with a magnitude of 6 meters that's making an angle of 37 degrees with respect to the x-axis. Every vector carries with it an x-axis and a y-axis at its tail. The x and the y components of the vector are measured with respect to this axis. To find the x component, you start at the tail, and you move in a line along the x-axis up to a point that's underneath the head of the vector. Then, you move up from that point until you reach the head of the vector. That will make your y component. So ax is our x component, ay is the y component. So that's how we can draw these. How do we actually find them? Well, we can use our right triangle trig. Cosine equals adjacent over hypotenuse, sine equals opposite over hypotenuse, tangent equals opposite over adjacent. And if we look at our angle that we're calling theta A, then we can see the opposite side is AY, and the adjacent side is AX, and the hypotenuse is the magnitude A. So solving across, we find that the x component AX equals A times cosine theta. We plug in our values, and we find that the x component is equal to 4.8 meters. Make sure your calculator is in the right mode. We can do the same thing for y, but with y we're going to be using sine because the sine has the opposite side. So we see ay over a is equal to sine, solve for ay, a times sine theta, plug in the values we know, a is 6 meters, theta is 37 degrees, and we find that the y component is 3.6 meters. Let's try again with another vector. This time, vector b has a magnitude of 5 meters per second and an angle of 124 degrees with respect to the x-axis. Something like this. Well, when we draw our axes that every vector has carrying along at its tail, we see that b is clearly pointing to the left of the y-axis. Therefore, if we look at the x component of our vector b, it must be negative. It must be less than 0. So how can we actually find the values of the y component and the x component? Well, there are two options. We can look at the unit circle, or we can do right triangle trig. The handy thing about the unit circle is that as long as the angle is made in standard position, that is, with respect to the x-axis, measuring counterclockwise, then we will always get the answer using the simplest expressions. bx over b is equal to cosine of theta, by over b is equal to sine theta. This just comes from the x and y values that you find on the unit circle, defined from different angles theta measured in standard position. So we go ahead and plug in our values. by is equal to b times sine theta, and we find 4.1 meters per second. bx is equal to b times cosine of theta, and we find negative 2.8 meters per second. Let's try this again with some right triangle trig. First, we have to identify a right triangle in our problem. Well, we've got the hypotenuse b, the left side, the component by, and the bottom would be the component bx, but bx is negative. We can't have a negative side on a triangle, so let's call it lx as the side, and we'll just remember that bx is equal to the negative of that. Well, with our angle defined inside the triangle, we'll call that theta, then the opposite side is still by, the adjacent side is bx, and the hypotenuse is b. But you have to be careful. These sides will not always be the same in all problems. Once we have these defined, we can find our lx is equal to b times cosine, that's 2.8 meters per second, and by is equal to b times sine, which is our 4.1 meters per second. Now you try. Suppose you have a vector c, which is a magnitude of 12 meters per second and makes an angle of 221 degrees with respect to the x-axis. That is to say, is pointing into the third quadrant, down and to the left. You find the x and the y components. You better pause it now, because I'm going to discuss the answer in 3, 2, 1. Vector c is in the third quadrant, so when we draw its axis on its tail, it's pointing down and to the left. The x component, pointing left, is going to be negative, and the y component, pointing downward, is also going to be negative. We can use our right triangle trig, or our unit circle trig, in order to find the values of the components. My preference is usually to use the unit circle. And so Cx is going to be equal to C times cosine of 221 degrees. Cy is going to be equal to C times sine of 221 degrees, which gives us negative 9.1 meters and negative 7.9 meters.